Very good morning, students. Myself, Pravat Behera, your chemistry teacher. Today, we are going to discuss the topic that is optical isomerism. Okay, so we are going to discuss the topic optical isomerism. That is, as you know, isomerism is broadly divided in two parts. One is structural and another is stereo. So under stereo, it is again mainly two parts, but one is optical and another is geometrical. So now geometrical isomerism is already discussed under class 11 curriculum. Now we are going to discuss the optical isomerism. Okay, that is the part of stereo isomerism. So mane paka stereo isomerism kon thila? Na stereo isomerism or stereo isomer means the compounds having same structure, but different arrangement of atoms or group in space. Stereo. Different arrangement of atoms or groups in space are known as stereoisomers. Is it clear? Under the stereoisomer, optical isomer or optical isomerism is one part. Talko, what do you mean by optical isomerism? You must have heard the word optics. Optics means that is related to light. Optical isomerism means it must be related to light. Now the question is which light? Is it any ordinary light or any specific light? Now we have to consider the plane polarized light. Which light? Plane polarized light. Okay. So it is not the ordinary light, it is plane polarized light. Any light can be converted into plane polarized light when it is passing through the nickel prism. When it is passing through nickel prism. Okay. So the instrument use kara jaye, that instrument is known as polarimeter. And polarimeter re generally sodium lamp use kara jaye. So sodium lamp ro ame the light pass hochi. So sodium lamp le the light emerge hochi. When it is passing through the nickel prism, it will be converted to plane polarized light. Okay. Tale optical isomerism or plane polarized light with a relation kon. First हम देखिले plane polarized light kon. तापरे हमें देखिबा how it is related to optical isomerism. If plane polarized means it is passing in a single direction, right? If the plane polarized light after passing through the compound, the direction changes. The direction change over either in the clockwise direction or in the anti-clockwise direction. So after passing through the compound, there will be two things. Either the direction will be changed or there will be no change in the direction. If the direction change over, then the compound is known as optical active. If the compound or the light no direction change no over, then the compound is known as optical inactive. All of you got this? If the direction of plane polarized light is changed, then that is known as the optically active compound. If there will be no change in the direction of the plane polarized light, then the compound is known as optically inactive. Okay, two things are there. If the direction change over, now it will be either in the clockwise direction or in the anti-clockwise direction. Clockwise direction means towards right, anti-clockwise direction means towards left. Okay. So if it is clockwise direction, then you can say it as dextro rotatory, and this is levo rotatory. Okay. So dextro rotatory and levo rotatory. So dextro rotatory can be assigned with the sign plus sign or small d. Levo rotatory minus sign or small l. Okay. Dextro rotatory and levo rotatory. ताले हमें डिस्ट्रोटेड कंपाउंड को केमती एक्सप्लेन करिबा the compound which is capable in rotating, again repeating, the compound which is capable in rotating the direction of plane polarized light towards right or in clockwise direction. Similarly, laboratory, the compound which has the capability in rotating the direction of PPL in the anti-clockwise direction or towards left. Okay. So can you assign small d small l or capital D capital L? It is purely small d small l, not the capital D capital L. Is there any difference between small d and capital D? Yes, difference is there. That is relative configuration. जोटा हमें बायोमोलिक्यूल चैप्टर देखिबा कैपिटल डी जोटा हम कहते डी ग्लूकोज और अमीनो एसिड्स आर एल सीरीज. So that is capital D and this is small d. So there is no relation between this small d and capital D. हाँ, so small d को हमें प्लस साइन देखो जे और कैपिटल डी को प्लस साइन में मेंशन करा जाए, but these are not at all related with each other. किसी relation ही नहीं रखा गया. मुझे बोला, don't be confused. Another thing, capital D, capital L, we can assign the nomenclature capital D, capital L from the relative position of the functional group or heavy group. But एटी हमें ଗୋଟେ compound देखि कहि परिबानी whether the compound is existing in the D form or L. कहि परिबानी. Theoretically that is absolutely impossible. Okay. Theoretically मेति कहि परिबा the compound is optically active or not. Okay. ताले हम केमि जानिबा ना कैपिटल डी कैपिटल एल ओनली एक्सपेरिमेंटली जाना पड़े जोटा में पोलरिमीटर इंस्ट्रूमेंट कथा कहले. Now the question is, ताले हम जानले ଗୋଟେ कंपाउंड ऑप्टिकल एक्टिव अछि एटा हला एक्सपेरिमेंटल मीन्स. Theoretical केमि जानिबा, because in the exam you cannot be given with the experiment or you cannot be given with the compound, only you will be given with the name or structure of the compound. ताले नेम और स्ट्रक्चर देखि हमें जानिबा केमति एटा तो एक्सपेरिमेंटल मीन्स हला पोलरिमीटर रे ना ता पे हमको देखिया पड़िबो ଗୋଟେ concept that is known as chirality. Okay student, यहाँ तो एपन तो क्लियर अछि. Next we have to check for the presence of chirality. Okay, the word chirality is coming from the Greek word cheer. Cheer means hand. Okay, it is derived from the Greek word that is cheer, that means hand. Then देखिए our hands are the mirror image of each other. हाँ, किसी पिलांकर एक्सेप्शन था स्टूडेंट मन पचारंती जे किसी पिलांकर 6 फिंगर थे. So in that case it is not the mirror image, or that is exceptional case. But in general, like we ordinary people, so we have the 5 fingers in both the hands. So both the hands are mirror image of each other. I hope all of you got this mirror image of each other. But these are non-superimposable mirror image. देखो, अब mirror image कहूँ जे, but जब हमें गोटे को आउट में submerge करिवा, superimpose करिवा, it is non-superimposable mirror image. So from this non-superimposable mirror image, the concept or the term chirality is derived. So chirality means non-superimposable mirror image. Non-superimposable mirror image. Okay, non-superimposable mirror image. ताले हमें डिफाइन केमती करिवा chirality term को, right? The compound which forms non-superimposable mirror image, is known as chiral compound or optically active compound. Chiral compound or optically active compound. So I hope all of you got this. ताले यदि हमें ଗୋଟେ compound नबा, suppose this, Okay. So if you are going to draw the mirror image of this compound, you will get this is the mirror image. Okay. If you are going to take this compound and try to put it with the other compound, whether these two compounds are superimposable or non-superimposable. These two compounds are non-superimposable mirror image of each other. Okay, you can see mirror image both are so non-superimposable mirror image of each other. बुझे पड़ला स्टूडेंट? अच्छा, ताले हमें आउ गोटे कंपाउंड नबा just to know. So its mirror image. Okay. Now can you see whether these are superimposable or non-superimposable mirror image? These two compounds. Check. These are superimposable mirror image of each other. These are superimposable mirror image of each other. So second compound is optically inactive, but the first compound is optically active. Second compound is optically inactive, but first compound is optically active because the first compound forms non-superimposable mirror image with each other. Okay. Next is theta compound optically active. What is the relationship between these two compounds? Isomers or not? Yes, obviously isomers. These two compounds are isomer of each other. Okay, because same molecular formula, isomer. ताले जो isomer है, अंको ना कौन को जीवो? ना these are known as the enantiomer. These are known as the enantiomer. Okay, so quickly note down enantiomer. If two optically active, isomers are not non-superimposable. If two optically active isomers are non-superimposable mirror image of each other, non-superimposable mirror image of each other, then those are named as enantiomer. Then those are named as enantiomer. Okay, students, you got it? Acha. Now, then हम कह theta को optical active अच्छी. If you know, the first one is existing in the D form. If the first one is existing in the D form, then the second one must be existing in the L form and vice versa. That means that write down from the enantiomeric pair, that is known as enantiomeric pair. From the enantiomeric pair, if one is existing in the D form, then its mirror image must be existing in L form and vice versa. Must be existing in the L form and vice versa. Okay. So the theta is got D form or L form. And another thing you have to remember, in order to be enantiomer, both the compounds must be optically active. That is the minimum or mandatory condition for the enantiomers. So note enantiomers must be optically active compounds. If the optically active compound no then we cannot name them as the enantiomer. Okay. अच्छा, I'm going non-superimposable mirror image. That empty about the two stereoisomers, not only optical isomer, stereoisomer, it can be geometrical isomer, are not mirror image of each other. I'm going two stereoisomers are not mirror image of each other. तो तांको ना कोन को जीवो ना दोज आर नोन एज द डायस्टेरियोमर. Then those are named as the diastereomer. Okay. So what is diastereomer? Write down if two stereoisomers are not mirror image of each other, then those are named as diastereomer. So I told these are the stereoisomers. You can take in the example cis and trans isomer. These are diastereomers. Similarly, you can take this okay. So the relationship between these two are a diastereomer and these two are also diastereomer. Quickly note down. Another thing you have to remember, diastereomer hava optically active hava kichi mandatory nahi. Diastereomers may or may not be optically active. Note down, student. Diastereomers may or may not be optically active. But ame enantiomer pe it must be optically active. For enantiomer it must be optically active. Note down. I hope it is clear. Enantiomer then diastereomer. Okay. Achha, any doubt? You can write in the chat box. Student, am I audible? Can anyone write in the chat box? Okay. Then student named Lakshmi Pujari, you have to check. You have to check your device. Okay. In case anything, you can write in the chat box. Thank you. Now the question is, I'm going to say optically active compounds are non-superimposable mirror image of each other, right? Or compound देखी कि हमें जानवा केमती whether the compound is optically active or not. तापे what is simple अच्छी we have to check for the presence of chiral carbon or chiral center. ताको asymmetric center भी कहती chiral carbon, chiral center, asymmetric center. So what is this? The most simple word रे कहवा chiral carbon, not chiral compound. Chiral compound is different, chiral carbon is different. If the carbon atom, खाली माने carbon में any atom, okay, हमें but एटी organic होचे, तो same concept हमें coordination compound रे भी आउटर पड़िबो. If the carbon atom is attached with four different atoms or groups, then that carbon is known as chiral carbon. Okay, then that carbon is known as chiral carbon. So we can mark this star to the chiral carbon. So देख परिबो the compound देछि, in this compound how many chiral carbon atoms are there? 2 chiral carbon. यदि ये carbon देखिले with this one hydrogen, one OH, one COH, and another this group. So chiral carbon. With this, one H, one OH, one CH2H, and another this group. That is chiral carbon. बुझा पड़ला ହେଲା अच्छा ताले हम देखिबा किछ कंपाउंड दोची you have to mention the number of chiral centers associated with it. Assign the number of chiral centers. Okay, these are the two compounds. You have to assign the star mark. Star mark कहाँ को assign करिबा to the chiral carbon. तो data compound रे mention करो how many chiral centers are present. Okay, second one also mention. First one also check. Student who have written 5, check it once again. Two, no. Okay, so second question try karo. We'll discuss both. Quick. And all of you try it. So should I discuss the answer? Okay. Now, see. In first, this is CS3, OH, then another H, and this is another group. Tal kon hela? Four different. What am I last dekhiba? It is CS3, it is also CS3. I mention karne just confusion fine. So both are CS3. Tale de gotte carbon seta two identical group hela, that is CS3 hela. It cannot be the chiral carbon. Here, this is 1, 2nd, 3rd, 4th, 5, 6, 7, 8, 9. Okay, friends, all of you got this. In the second, 9, and first, 4. Can you write in the chat box? Second रे 8 केमते हबो सेटा बे डिस्कस करिया तो कार मिलत रहा ओके चल देखो एटी हम देखिबा second and 9, sorry, second and 9, first 4. Okay, good. See, there is no difficulty. I think these 5. It is the ye chatta bhi kich problem nahi. Student ka confusion houthibo regarding this and this. Okay. Now see, with this carbon, one NH2, another this group, 2 different egala. Tapre hum jodi top re jiba, CHOH, bottom CHOH, then CHCl, again bottom CHCl, then this is common. Tamane kon kaiba? A carbon pai, both the sides are identical. Similarly for this, gote bromine, another hydrogen achi, baki top and bottom both are identical. Tale kon hela? These two are the these are achiral centers. Okay, these are the achiral centers, not chiral centers. Friend, is this clear? I hope all of you got this. Any difficulty? If any difficulty, quickly write in the chat box. No? Okay. So, okay, out it. Okay. Shubham, which one? First or second? Second. Okay. Now see, Jidam dekhiwa. For this carbon, one is bromine, gote hydrogen to achi, and gote CH3. So another, the remaining chain. Tale kon hala 4 different egala chiral center. For this, one is CTH5, another is C2 bromine H4. Then this is one hydrogen, a remaining group. So this is also chiral center. Similarly, this is chiral center. This is chiral center. This is also chiral center. ये 5 रे किस problem नहीं. यदि हम एक कार्बन देखिबा, one hydrogen, one OH, this is another group, this is another group. ये भी chiral center ले. ये 4 भी ठीक अछि. यदि हम ए दिरे कार्बन जोटा हम सर्कल करछि, ताको यदि हम डिस्कस करिबा. देखो, one is NH2, another is the chain. 2 different हे गेले. Then move up CHOH, move down again CHOH. Then CHCl, CHCl. This is common. तामन कोइबा, for this carbon, both the above and below groups are identical. So this is achiral. Then हम एठी देखिया bromine, एठी कोन ना bromine, hydrogen. Both are 2 different atoms. Again moving off CHCl, CHCl, CHOH, CHOH, and this is common. Tale kon hela? These 2 are identical. That means this the carbon present here and the carbon present here, both are achiral carbons. Okay. So is it clear, students? Any doubt up to this? Shubham, now your doubts clear? Okay, good. Now moving to the next. Fisher projection formula. Fisher projection formula. So what is Fisher projection formula? हम जो organic compound देखुचे, जब हम organic compound देखुचे, those are the 2-dimensional or 3-dimensional. हमें एठी कोचे chiral carbon. Chiral carbon means that must be tetrahedral. Okay, 4 different atoms of group. Tetrahedral means that is 3-dimensional. So 3-dimensional है कौन रहेगा? Now one atom or group will be above the plane, another is below the plane, and 2 will be present on the same plane. So that means 3-dimensional. So 3-dimensional form को हम उधर 2-dimensional form रे हमें vertical and horizontal line रे जो express करूचे, that is known as the Fisher projection formula. Okay. So what is Fisher projection formula? It is the 2D representation of 3D structure. Okay. It is a 2-dimensional representation of 3D structure by the help of vertical and horizontal lines. By the help of vertical and horizontal lines. Is it clear? जेमने हमें आ पूर्व स्ट्रक्चर जते डिस्कस करिथिले this. Okay, the diagonal लिखा है that is also the Fisher projection formula. These are also the Fisher projection formula. These are the two-dimensional representation of the three-dimensional structure. Okay, 3D structure को हमें 2D structure रे vertical और horizontal line रे ताको represent करूँचे. अच्छा, now the question is, suppose you have written the structure. So this is the structure, and someone has written this structure. Okay, so what is the relationship between these two? Can anyone say? What is the relationship between these two? Yes, write in the chat box. Yes. Anyone? Student naming तबे निजे try कर परिवो. एबे हमें दिस सब क्वेश्चन नेमिंग लिखिबा. Then हमको जो अछि 1.5 hour भितरे ऑप्टिकल आइसोमेरिज्म टॉपिक हमें कंप्लीट कर परिया. Anyone? What is the relationship between these two? Still waiting. No, these two are identical structures. The relationship between these two are identical structures. Okay, identical structure. Tell केम जानिबा ना फिशर प्रोजेक्शन फार्मूला को हमें रोटेट करि परिबा. Write down rotation in Fisher formula. Rotation in Fisher formula. Right. Point 1. Rotating by 180 degree or its multiple. Rotating by 180 degree or its multiple makes no change in the Fisher formula. Okay, rotating by 180 degree or its multiple makes no change in the Fisher formula. एटी हम देखो एक्जेक्टली 180 डिग्री रोटेट करै छै. ताले यदि 180 डिग्री किछि यदि चेंज न हबो ताले ताको भितर रिलेशन कोन रहला ना आइडेंटिकल स्ट्रक्चर. बाय रोटेटिंग 180 डिग्री यदि कि चेंज न हबो ताले रिलेशन कोन रहला आइडेंटिकल स्ट्रक्चर. ओके स्टूडेंट, इज इट क्लियर? अच्छा, नेक्स्ट नेक्स्ट कोन ना नेक्स्ट हैला आउ किछि रोटेट करि परिबा कि? सपोज हमें ए कंपाउंड नेले. Okay, you can keep any one of the atom or group. Suppose this one. You can keep any one of the atom or group fixed, and the exchange among all others, that is all other means remaining 3 rahila. So it can be either in the clockwise direction or anti-clockwise direction. Jodi ame eta anti-clockwise direction lekhuche tale kon hobo? You can see the structure. OH the fixed rahila, baki rahila this is H, CH3 and C2H5. So what is the relationship between these two? Again identical. তাহলে যদি সিঙ্গেল কাইরাল কার্বন ଅଛି বুঝিপারছ স্টুডেন্ট যদি সিঙ্গেল কাইরাল কার্বন ଅଛି তাহলে আমি কোন করিবা না by keeping note down by keeping one of the atom or group fixed by keeping one of the atom or group fixed exchange among all three in both clockwise or anti-clockwise exchange among all three in both clockwise or anti-clockwise makes no change in the compound makes no change in the compound okay so it is clear अच्छा जेमते हमें ए कंपाउंड को हमें कौन करिवा फिक्स रखिले लेट्स से CH5 बाकी हमें आपको क्लॉकवाइज रोटेट करो so by doing so CH5 is there okay now coach CH5 is there then clockwise means it is H this is CH3 this is OH so relationship between these two compounds are identical compounds student जदि नोट करि पालनी नोट करो by keeping I'm गोटे काइरल कार्बन कथा कहूचे by keeping one of the atom or group fixed exchange among remaining three in both clockwise or anti-clockwise exchange among remaining three in both clockwise or anti-clockwise is allowed and there will be no change in the compound तार रीजन कोन देखो स्टूडेंट हम कहले 3 डायमेंशनल सो 3 डायमेंशनल को हमें को साइड रो तक व्यू करूचे okay from which side you are observing the compound so the relative position will be changed okay the relative position will be changed like suppose you are looking at me okay so गोटे स्टूडेंट मतलब फ्रंट देख पारे गोटे स्टूडेंट लेफ्ट साइड देख पारे गोटे स्टूडेंट राइट साइड देख पारे so कोन समस्त कर व्यू अलगा हो but the object or जते मते देखुछो so I am the same object but the observation is different from different angles or different sides similarly I am कहबे ए दिटा compound same अछि you are someone is observing from this side someone is observing from this side so the position of the atoms or groups are different so this is what the rotation means बुझि पारलो if there is two or more than two chiral centers if there are two or more than two chiral centers like this suppose you are taking okay so how to perform the rotation again 180 degree or its multiple that is going to make no change in the compound 180 degree or its multiple is not going to check any change in the compound okay acha ताले आउ कोन रहइबो ना हमें any atom or group को फिक्स रखिबा any atom or group को फिक्स रखिले गोटे काइरल सेंटर को सॉरी गोटे काइरल सेंटर फिक्स रखिले नेक्स्ट काइरल सेंटर को हमें क्लॉकवाइज और एंटी क्लॉकवाइज को पोजीशन में रोटेट करि परिबा ओके सो बाय डूइंग सो what will be the compound bottom chiral center is fixed now you can check okay so the relation between these two are identical okay relation between these two are identical similarly यदि हमें गोटे कंपाउंड नबा where three chiral centers are present Okay. So you can rotate any one of the chiral center by keeping, so this one, by keeping the rest fixed. ଆମେ ଯାହା ବି rotate କରିବା, that will be among the atoms or groups present with single chiral center. Okay. Student is asking the second. देखो, हमें ये दिया भितर any one chiral center को fix रखिबा. Okay. So I have kept the second one, that is the bottom one, so fixed, and we can extend the position among the these three, either in the clockwise direction or in the anti-clockwise direction. By doing so, there will be no change in the configuration. By doing so, there will be no change in the configuration. Okay. So student, it is clear. More than 2 chiral center achi, now we have to keep remaining chiral center fixed. Only one, about 1 chiral center, the position can be exchanged either in clockwise direction or in anti-clockwise direction. So this is what the meaning of rotation in the Fisher projection formula. Rotation in the Fisher projection formula. Okay. Next is absolute configuration. Absolute configuration or R and S nomenclature. Absolute configuration or R and S nomenclature. Okay. Achha. So what is the need of absolute configuration or R and IS nomenclature? Then we discussed before some time, from the chiral center or from the chiral carbon, we cannot assign either D or L. I mean, theoretical देखी कोई परियन whether the compound is existing in the D or L form. Okay. ताले मटे chiral center को mention केमती करे कि chiral compound को mention O form रे का nomenclature केमती assign करे. So in order to assign the nomenclature, we have to take the help of absolute configuration or RS nomenclature. So R and S derived from R stands for rectus, S stands for sinister. Rectus means clockwise or towards right. Sinister means anti-clockwise or towards left. Anti-clockwise or towards left. Okay. So assign केमती करिवा? How to assign R and S? एटा में theoretical कही परिवा. जो हमें DL को थे, that is absolutely practical, but this one we can assign it by theoretical means. गोटे compound देखे में कही परिवा, हला? And it must be chiral compound. It must be chiral compound or chiral center. Better to say chiral center. ताले केमती assign करिवा? Let's say it is NH2 OH H CH3. Write down assigning RS nomenclature. This is one of the important topics. Assigning RS nomenclature. It is only for the chiral carbon. It is only for the chiral carbon, right? So you must have read EZ nomenclature. जो हमें geometrical isometry discuss करते हैं EZ nomenclature. So EZ nomenclature assign करे पे हम कौन थिला? We have to follow for assigning EZ nomenclature. We have to follow sequence rule, CIP nomenclature, or ताको हम कौन कहते हैं? Priority rule. Priority rule, sequence rule, or CIP nomenclature. जो student भूल जाए तो मैं तुम्हारे उधर dictate करूँगी, but explain कर दूँगी. कौन थिला? First point थिला. एटा priority rule माने हम जो चारटा atom के group present अछंती with the chiral center, we have to assign the priority. We have to assign the priority to the 4 atoms or groups present with the chiral carbon. And priority कौन थिला? First point कौन थिला? The more the atomic weight of the directly bonded atom, again repeating, more the atomic weight of the directly bonded atom, more is the priority. Okay, that is first one. जो मैंने भूल जाए तो just quickly note down by yourself. More the atomic weight of directly bonded atom, more is the priority. So OH, oxygen, then nitrogen, then carbon, then hydrogen. 1, 2, 3, 4. That is first. Second rule, चाहूँ तो निजे नोट कर दियो. यदि डायरेक्टली बॉन्डेड एटम सेम थी सपोज CH3 अच्छी CH5 अच्छी तो से केस रे केमते लिखिबा ना इफ डायरेक्टली बॉन्डेड एटम्स आर द सेम then we have to look into the next atom for deciding the priority. Repeat करछि, if directly atoms are the same then we have to look into the next atom for deciding the priority. This is the second point. Okay. Third कौन? The third is if any multiple bond is present, then that will be considered as the multiple bond number of single bonded atom. Then that will be considered as the multiple bond number of single bonded atom. ता माने carbon triple bond nitrogen जो देछि, so that will be considered as C3 single bonded nitrogen. C3 single bonded nitrogen. Carbon double bond oxygen, so that will be considered as carbon 2 single bonded oxygen. Okay, carbon 2 single bonded oxygen. Is it clear? Okay. So these are the atoms of groups. I'm assign kale. First I'm going to RS nomenclature पे. Now we have to use the sequence rule or priority rule or CIP nomenclature to assign the atoms of groups present with the chiral carbon. Okay. Then second कौन? ना देखिबा second लेखो. Second rule है RS nomenclature पे. Locate the position of the fourth priority group. Fourth priority group, that means whether horizontal or vertical. Whether horizontal or vertical. Okay, fourth priority group of position कोड अछि horizontal की vertical सेटा मु देखियो पड़ो. Okay, that is second. तापर हम देखिबा next कोन third first is third if lowest priority group is at the vertical position. If lowest priority group is at the vertical position. तले केस रे कोन ना first the arrangement of 1 2 3 clockwise. The arrangement of 1 2 3 clockwise, then R. If arrangement of 1 2 3 anti-clockwise, then S. Okay, the arrangement of 1 2 3 clockwise, then R, and arrangement of 1 2 3 anti-clockwise, then S. Already देखो, where is the position of our fourth priority group? That is at the vertical position. Then what is the arrangement of 1 2 3? First you have to see 1, then 2, then 3. It is clockwise or anti-clockwise? 1 2 3 anti-clockwise, then S. Okay. Then quickly note down. You can write one more compound. Now see, by using priority rule, assign the atoms or groups the priority. This is first, this is second, this is third, this is fourth. Check कर दियो. All four are carbon directly bonded atoms. All four are carbon atoms. Then after carbon, we have to look into the position of or the next atom. 2 oxygen. This is 2 hydrogen, 1 oxygen, only hydrogen, only carbon. two oxygen first, then oxygen, hydrogen second, then carbon third, and hydrogen fourth. Okay. So asiala. Next देखिवा, where is the position of the fourth priority group? Fourth priority group is present at the horizontal position. The horizontal position of the vertical student wait. जे भी किसी question पचार doubt. Okay, I am coming to you. Just wait this. See, if lowest priority group is present at the vertical position, then 1, 2, 3 clockwise R, 1, 2, 3 anti-clockwise S. So the reverse लिखिवा 1, 2, 3 anti-clockwise. Our etikon rahila horizontal position. Then R 1, 2, 3 clockwise. Then S. Or just reverse likhi diyo. Fourth rule lekho. If the lowest priority group, is at the horizontal position, lowest priority group is at the horizontal position. Then first 1, 2, 3 clockwise S, or just opposite age 1, 2, 3 clockwise S, and 1, 2, 3 anti-clockwise R. 1, 2, 3 clockwise S, 1, 2, 3 anti-clockwise R. Okay. Note down. अच्छा, numbering student just take a पूर्व कहली शुभम, you have to use the priority rule or sequence rule जोटा में each and nomenclature करथिले जदि भूल जायछ आउतरे ताको जेकी रिवीजन कर दबो. ऑलरेडी मैं एक्सप्लेन करली. एक्सप्लेन कौन थिला ना, more the atomic weight of directly bonded atom, more is the priority. Second rule थिला, if identical atoms are the if directly bonded atoms are the identical, then for deciding priority we have to look into the next atom. Third कौन थिला ना, if multiple bond is present, then that will be considered as multiple bond number of single bonded atom. Carbon double bond nitrogen means carbon 2 single bonded nitrogen for deciding priority. Okay, so these are the rules. Other the isotope thibo, isotope to means different atomic weight hegala, jahar atomic weight adhika thibo tar priority adhik. Shivam, I hope you got it now. Friend, upon the clear. Acha, ताले गोटे chiral center काहेकि जदि गोटे रु अधिक chiral center थिबो ताकु हमें आरएस नोमेनक्लेचर रे मेंशन करि परिबो. तार गोटे एटा क्वेश्चन दउची, नोट करो. Iodine, you have to assign the RS nomenclature to all chiral centers. So these are the questions. Try. Student all of you trying? Quick. If they try karibo, first you have to mention the priority to the atoms or groups. Second, you have to check for the presence of the lowest priority group, horizontal or vertical. The lowest priority group vertical achi, then the remaining 1, 2, 3 clockwise are and anti-clockwise S. The lowest priority group horizontal achi, remaining 1, 2, 3 clockwise S, anti-clockwise R. I hope all of you tried. So, as I explained you, you have to revise the CIP nomenclature or priority rule once. तापर जे हमें ताको नंबरिंग कर परिया जोटा कि हमर ज्योमेट्रिकल आइसोमेरिज्म EZ नोमेनक्लेचर रे डिस्कस होइतला ओके अच्छा स्टिल जतबे नंबरिंग डिफिकल्टी होची देखि दे बे आउथरे ताको डिस्कस करूची दिस इज वन कायरल सेंटर दिस इज अनदर कायरल सेंटर ता माने हम RS नोमेनक्लेचर दुईटा कायरल सेंटर को असाइन करिवा टू दिस कायरल सेंटर वन हाइड्रोजन वन OH वन COOH and another this group 4 different are present. Okay. So, let them देखिबा lowest priority रहला H. This is fourth one. Then directly bonded atom oxygen. देखिबा directly bonded atom carbon. Sorry, hydrogen, carbon, carbon, then oxygen. Oxygen is 1, hydrogen is 4. Next. This one, carbon, after carbon, double bonded oxygen and single bonded oxygen. That means you can consider after carbon, 3 oxygen atoms are there. But with this, after carbon, 1 hydrogen, 1 carbon, 1 oxygen. So obviously, this is second and this is third. Similarly, the next point, next is hydrogen, fourth, and this is first. Oh, direct bond oxygen, then carbon, carbon. With carbon, 3 oxygen, and with carbon, 1 oxygen, 1 carbon, 1 hydrogen. Okay. Now, in the first, second one, fourth priority group is at the horizontal position, and the remaining 1, 2, 3. It is clockwise or anti-clockwise? Anti-clockwise. Horizontal, anti-clockwise. R. Then here, in the first one, it is horizontal, and the remaining 1, 2, 3 clockwise. This is S. Okay. So, if the question is option 2R, 3S, 2S, 3R, like this. So, 1, 2, 3 mane, 2R, 3S. They say 2R, 3R, 2S, 3S, 2R, 3S, like this. So, 1, 2, 3, 4 means that is according to IPSC. Both the ends are carboxylic group. So, we have numbering 1, 2, 3, 4 or 1, 2, 3, 4. So, 2 and 3 both chiral atoms are present. So, with 2 you can assign R, with 3 you can assign S, or reverse is also possible. That means if you are writing 2S, 3R, this is also correct. That is identical. But एक case में मुझे देखिए numbering रे 1, 2, 3, 4, 5. Okay. So it is chiral center के क्या 2, 3, 4 are chiral centers. 2, 3, 4 are chiral centers. Okay. So it is different configuration of it. Now come to the next. I hope first question is clear to all of you. Okay, now come to this. The lowest priority group is hydrogen, 1, then carbon, nitrogen, iodine. So highest mass is iodine. Okay, and second nitrogen, third carbon, and hydrogen is fourth one. So where is the position of the lowest priority group? That is horizontal. And what about the remaining 3, 1, 2, 3? This is clockwise. So S. Okay. So it हम जो देखिवा 1, 2, 3, 4, 1, 2, 3 anti-clockwise R. What is the relationship between these two? These two are enantiomers. These two are enantiomers, right? So enantiomer and one is R, another is S. जेम तुम कहती enantiomer pair रे कौन थिबो गोटे D थिबो जदि तार mirror image R थिबो. Similarly, जदि गोटे R रहिबो then the other one must be S in the enantiomer pair or in the mirror image. Okay. So here you can assign it is fourth. This is 1. Then this is 2. And this is 3. So 1, 2, 3. It is clockwise. So this is 2 S because horizontal clockwise. Again it is 1. This is 4. 1. This is 4. Next one driver. Now this is carbon, oxygen, carbon, hydrogen. It is carbon, oxygen, carbon, hydrogen. तापर एटा एटी कोन 2 डबल बॉन्ड ऑक्सीजन अछि एटी 2 डबल बॉन्ड ऑक्सीजन नाही. So it is 2 and it is 3. तारा कोन करिबा 1, 2, 3. It is anti-clockwise. So 3 R. Then comes to the last one. It is 4th. It is 1. Then 2 hydrogen, 1 oxygen with this carbon. Hydrogen, oxygen, carbon. So this comes 3rd and this comes 4th. Then 2nd. 1, 2, 3. 1, 2, 3. This is again clockwise. So it is 4S. 2S, 3R, 4S. Quickly note down. So I hope all of you got what is RS nomenclature. Any doubt up to this? Write in the chat box. And take 2 minutes and complete the structure. Completed? Yes, 4S. Clockwise and horizontal. Clockwise, horizontal is S. So I hope RS nomenclature is clear. अच्छा, हमें देखिए first compound देखो. First compound, both the chiral centers are present and this compound contains, I'm going to outside draw करछे. Can you say this plane is imaginary plane and it divides the molecule into 2 identical halves? the imaginary plane which is dividing the molecule into two identical halves, that कौन कहा जाए ना symmetry plane. This is known as symmetry plane. Okay. ताले यदि type of symmetry plane present थिबो, plane of symmetry present थिबो, and the compound contains more than one chiral center, then that compound is optically inactive. Then that compound is optically inactive. Okay, so note down. If the compound contains more than one chiral center, then it can be optically inactive. Then it can be optically inactive if it contains any symmetry element. If it contains any symmetry element, so which type of symmetry? Now it can be then plane of symmetry or center of symmetry. Plane of symmetry or center of symmetry. So if this type of symmetry element is present, then the compound E becomes optically inactive. So that is known as major compound. These compounds are known as the major compound. Major compound कौन होची ना जदि गोटे कंपाउंड रो गोटे दीटा कायरल सेंटर अछि गोटे कायरल सेंटर ताकू रोटेट करूची क्लॉकवाइज रे आ गोटे कायरल सेंटर ताकू रोटेट करियो एंटी क्लॉकवाइज. Suppose this one it is plus x degree, this one it will be minus x degree. So plus and minus both will cancel each other. So overall resultant कौन होबो ना optically inactive compound. ताले हमें जे देखिबा one chiral center, one chiral center always optically active. Okay. Then second, more than one chiral center, more than one chiral center. तादर कौन देखिए first, no symmetry element, no symmetry element, so optically active. Second, symmetry element present, then कौन होबो optically inactive. Optically inactive. Quickly note down. If the compound contains single chiral centers, then without any question or without any doubt, you can immediately write the compound is optically active. If more than one chiral centers are present, then हमको देखिए पड़िबो whether any symmetry element is there or not. If no symmetry element, then optically active. If symmetry element is present, then optically inactive. ये देख पाते हो symmetry element अच्छी. Okay, so this compound is optically inactive. Optically inactive. Quickly note करो student. जैसे हमें out question देखिबा, out compound देखिबा, this one. उधर लिखा तो 2s, 3r, 4s. So it contains three chiral centers, but there is no symmetry. अब देखियो terminal देखियो गोटे CHO और गोटे ला CH2OH. यदि symmetry नहीं, then this is optically active. Okay. ताले more than one chiral center, but no symmetry, optically active, and only or more than one chiral centers, but symmetry is present, so optically inactive. So optically inactive. So clear? Yes, that I'm going that is major compound. So that is clear. तार में जदि ए दिटा देखिले enantiomer अछंती जदि ए दीटा को कंपाउंड गोटे मिक्सचर रे थिबे with equal moles ताले कौन कहजिबो ना रेसिमिक मिक्सचर मेजर कंपाउंड देखिथिले एटी रेसिमिक मिक्सचर ताले रेसिमिक मिक्सचर लिखो if equal molarity जोटा हम लिखो गोटे सॉल्यूशन से मोलारिटी होबा equal molar concentration of enantiomers are present equal molar concentration of enantiomers are present then those are then that mixture is known as racemic mixture then that mixture is known as racemic mixture so जब हम compare करिबा between the previous and this एठी कोन it is optically inactive and within the compound two chiral centers one is R another is S एठी हम देखिछे two different compound enantiomer one is R another is S so this mixture is optically inactive this is also optically inactive so आपको हम कोन कहले ना this is racemic mixture it is meso compound means within the compound and racemic mixture means two different compounds both are optically inactive now हम जे देखिबा meso compounds are optically inactive काहे कि ना within the compound opposite rotation is present एटा क्विकली नोट करि परिबो meso compounds are optically inactive due to internal compensation whereas racemic mixture is optically inactive due to external compensation now we have taken two different compounds so these are optically inactive by external compensation and the first one is optically inactive by internal compensation I hope it is clear ताले हम एनांशियोमर को सेपरेट करि परिबा ना नहीं जोटा हम रेसिमिक मिक्सचर सेपरेट करि परिया एस that process is known as resolution right from the enantiomeric pair a racemic mixture better लिखो from the racemic mixture two isomers can be separated by the process known as resolution okay one student has asked what is the difference between internal compensation and external compensation so हमें देखिले enantio एठी जो रहला racemic mixture is optically inactive due to external compensation ता माने कोन हमें this compound we have taken with equal molar concentration equal molarity अछि equal number of moles अछि ताले कोन ना this compound as the rotation हबो ता rotation को से काम करछि externally ताको cancel out करछि यदि plus y हला ये minus y ताले कोन हला externally cancel out हेगला so that is known as external compensation जब एठी देखिए मेजर कंपाउंड रे within the same compound यदि a chiral center plus x होछि a chiral center कोन होछि minus x होछि ताले कोन हला ये जो cancel out होछि that is internally cancelling each other ता कोन होछि internal compensation okay student is it clear okay so we have discussed up to this, that is optical isomerism. Our alpo tike rahiyala taku ame second class more achi. So in the beginning of the second class, we'll discuss that. Then we'll go to some important reactions of hydrocarbons. Okay. Okay, friends, take a break for 15 minutes. Then after the break, we'll start again.